A very good morning. I welcome you for the lecture series in the course Mechanics of Solids. And last class we have seen two different bodies. One is a rigid body and deformable body. Hope everyone is aware of what is a rigid body and what is a deformable body. So let us just recap the same. The rigid body which does not deform on externally applied load, and a deformable body which deforms and changes in shape and size when an externally applied load. And we have studied what is stress and strain and Hooke's law. And we have taken certain examples like crash test of a car and a hammer used for nailing a nail. And these are all the things we have seen in the last class. So in this class, we will discuss about the three different stresses. One is tension, another one is compression, another one is shear. So exploring these fundamental forces that shape materials and structures in engineering. So let us all look into the empathy part of this lecture. So we have a beam bridge here, a rigid solid structure that is resisting on two piers, one on each side. So whenever there is a load, there is a compression on the piers, and there is a reaction force from the bottom of the pier, and we have a tension as well as compression. So coming to the definition of stress, as we have already seen, stress is the internal force applied per unit area, and the SI unit is Pascal or Newtons per meter square. That stress depends on the direction and nature of applied external force. So coming to tension stress, how it works, that force pulls and elongates object along its axis, creating internal resistance. A common example, we can see a wire or cable hanging with the weight stretches under tensile stress, and the material response, it elongates to resist tension. Excessive force lead to nicking and fracture. So that normally the transmission high tension cables of electricity board, we can see in the every city in the roadside, they kept large pylons to carry that particular high HT cable. So compression stress is a squeezing force. Normally we have columns to understand better that forces compress and shorten objects along their length. Structural examples like column, pillars, foundations experiences compressive stress from loads above. So the material advantage is most materials withstand compression better than tension, particularly brittle material like concrete. So coming to the third and last stress of the type shear stress, that is a sliding force. So the force acts along parallel but in opposite direction on different parts. So the deformation mode is layers slide over each other and changing shape without volume change. Potential failure, excessive shear can cause layers to separate, leading to shear failure. So the best example is scissors that we have equal and opposite force in the opposite direction, and the shear failure is happening on the cloth or any material which we use to shear that using a scissor. So visualizing three stresses, that is tension, arrows pulling apart along the length, material elongates and thins, compression, arrows pushing together along the length, material shortens and bulges, and arrows sliding past each other on parallel planes. So layers displaced laterally. So why these stresses matter in engineering? So we have structural design, bridges, buildings, and infrastructure depend on understanding how forces distribute through components under varying load conditions. So the material selection, choosing a material with appropriate elasticity, strength, and failure characteristics is critical for safety and performance. And failure prevention, anticipating how forces acts on components prevents catastrophic structural failures and ensure long-term reliability. So let us summarize this forces. We normally remember this by using a common acronym that is TCS, tension, compression, and shear. So each stress type causes unique deformation and requires specific design considerations. Mastery of these concepts ensures safer, more and efficient engineering solutions. So this is a small mind map to remember what we have discussed so far. So in this tension stress, it is being branched into stretching forces, elongate objects along axis, material thins, and next example hanging wire or cable that should be remembered about this. And we have a small assessment quiz for you. And finally, the reference for further learning. So thank you all for your kind attention on this topic. Let us have a very beautiful topic in the next and forthcoming classes. So we can go through the reference to find more and explore more. Thank you.